This is a Stevens Supremathic, an interesting slide rule made in France in the early part of the 20th century. It's got a circular form factor, but it doesn't really work anything like any other circular slide rule I've ever seen. It's a handheld device, obviously. It's got a little arm that you can pull out from the left side so that you hold it in your left hand as you operate it with your right hand. It's made in aluminum. It's dense and heavy. It's quite thin. It's very elegant. It features two dials. There's a front dial and a back dial. The front dial is entirely clear, except for two cursors that are inscribed on its reverse side. One of them is black and it's here. The other is red and it's here. The red one is the primary cursor. The black one is used for doing certain conversions. The front dial can be turned by means of this rather large knob, either direction. Notice that when I turn the front dial, nothing happens to the back dial. It stays completely stable. The same is not true when I do the reverse. If I turn the back dial, which is done by just grabbing its edge, which is exposed over the device from about the 11 o'clock position to 4, the front dial is moved with it in either direction. So again, the front dial moves independent of the back, but it also moves dependently with the back. Another interesting feature is that the front dial, when turned in the clockwise direction, hits a hard stop when the red cursor is at 12 o'clock. It just won't go past. You can turn it in the opposite direction as much as you like. But when that red cursor moves past the 12 o'clock position, you'll hear a little click as some sort of a ratchet locks in so that, again, you can't move it back past 12 in the clockwise direction. So the way this all works, you have to pay attention to how the scales are laid out. There's a scale on the back dial which runs in the counterclockwise direction. And there are two scales for the front dial. One runs in the counterclockwise direction outside of the dial, here, and the other runs in the clockwise direction on the inside of the dial, here. You can use these scales and the dial mechanism to do multiplication and division quite easily. First, you start by turning the back wheel until some desired number appears under the red cursor at the 12 o'clock position. Let's pick, say, 1.2. There we are. We have 1.2 or 12 or 120 in the usual decimal ambivalent way a slide rule works underneath this fixed cursor at the 12 o'clock position over the back dial. You then turn the front dial until it hits that hard stop at the 12 o'clock position. And we've now got the red cursor on the front dial lined up also underneath 1.2 on the back dial. You then start turning the back dial counterclockwise, and again the front dial will be carried with it as you do. Now if you're doing division, you use the outer dial. If we're dividing by 2, we keep on turning until the front red cursor hits 2 on this outer scale. So that's where we are. And then if you look up here, the back dial has been turned 2 as you've been moving it, and the number 6 or 0.6 now shows at the position of the top cursor. If instead we were multiplying 1.2 by, say, 3, would continue moving the front dial by means of the back dial until the red cursor on the front dial hits 3 on the inner scale, right there. And we've now multiplied our initial number, 1.2, by 3, and so we have 3.6 sitting underneath the fixed cursor at the 12 o'clock position. So that's how it works. There are some additional features of the slide rule. This one has 3 log scales for doing exponentiation on the back here. It also has a sine and a tangent scale on the back. That's the sine, that's the tangent. And they kind of work in an obvious way. There are little fixed cursors in each of these windows, and if you put an angle underneath the cursor in either of these two windows and then flip it over, you'll find that the sine or the tangent of that angle is displayed here on the back dial under the 12 o'clock cursor. The log scales work similarly to the way they would on any other slide rule. You pick a base, line it up underneath the cursor, flip over to the other side, turn the dial to a exponential position, and flip back, and the base will have been raised to that exponent under one of the other cursors. As interesting as the device itself is the way the device works, and no one who actually owns one of these has been willing to take it apart and see exactly what's inside, but by thinking about it, we can draw some reasonable conclusions. One of them is that the mechanism that ties the back dial to the front dial and makes it move, even though the front dial will not move the back dial, is just some sort of friction linkage. Friction linkages are used on lots of older slide rules. Otis Kings use a friction mechanism, as well as the Fuller cylindrical calculators. So I thought it would be interesting to at least think about how that mechanism might work. And I've built a model that shows one possibility. I don't actually think it's the way the device is actually constructed. But it's got to be something in the same vein, and I have some other ideas for how it could be done, and maybe I'll build another model that does it in a way that I think is probably more like what's inside the actual Supremathic. But anyway, here we have a device rendered in plastic. It's rather thicker than the actual machine, but it will show some of the same principles, hopefully. This device features two dials. There's a back one, which, as we can see when we move it, it moves the front one, and there's a front one, and we can see as we move it, it does not turn the back one. And there's also a ratchet so that the front one hits a stopping point right there where it will not turn further even though the back one is turned. And we can also see that if we move that fully around in the counterclockwise direction, there'll be a little click as the ratchet kicks in and prevents the front from turning further in the clockwise direction. The way this actually works, the front dial here is just friction fitted to its hub with a couple little wedges of brass, and so we can take the dial off the hub by removing those wedges. And then I've just got this thing kind of pinned together with a couple nails, so we can remove them. And we can take off the face. And we can see the linkage mechanism underneath. Here's the hub that the front dial is normally attached to. And here's the back dial with a hub of its own. And these two hubs have just got a layer of felt sandwiched between them. So when you turn the back one, the front one turns because the felt exerts enough friction on the inner hub to carry it along with the back as you turn it. But there's a great deal of friction on the back when the entire mechanism is holding it together, and that friction is higher than the friction here, so that if the back is held just slightly and you turn the inner hub, that friction bearing of the felt is slippery enough that it does not turn the back along with it. And it's really just a very little bit of friction you need on the back. And of course the ratchet mechanism prevents the front hub from turning past the 12 o'clock position. So that's what maybe that may resemble what's inside the actual Supremathic. It's probably not completely accurate, but I think if you consider the possibilities, you probably find that something along those lines is what must be going on inside the Supremathic itself. Lovely device. A lot of fun to play with, really nice to have. Hope this has been instructive.